guys, we're just going to look at the structure of solid, liquids and gases for today's revision session. Got a funny picture here about a cat. You might know some of this from chemistry, so that'll be really, really helpful actually. So let's have a look. So these are the images for a solid, liquid and gas. Now, a solid, between particles there are bonds, usually covalent or ionic, and they make the solid keep its shape. So the intermolecular forces are really, really strong. Okay, they can't be compressed, so they keep the shape that you put them in. What you can do is break those bonds by adding energy. So when you break those bonds and add energy, you make liquid. Now liquids are still incompressible, which means all the particles touch each other, but they're able to move around each other. Okay, so there are still bonds, like hydrogen bonds, but they're much, much weaker than in the solid. And then in the gas, if you heat the liquid, you can break those bonds again, and then you make the gas, and the particles can separate and they move around really, really quickly.
Grammarly does more than catch errors. With Grammarly, you can find... So I wanted to talk to people about the different states of matter, solid, liquid, and gas, using water as an example. But I thought first I better be sure that we're all on the same page about what water is made of. What's water made of?
Water?
Yeah. What makes water?
Water.
Okay, what elements does it take to make water?
H2O.
So what does that mean?
That it's water.
What elements? Water and cold. Water plus cold. But what does the H and the O mean?
Something in oxygen.
Something in oxygen.
Hydrogen.
There you go.
Hydrogen.
Hydrogen and oxygen. What's the 2 mean?
Hydrogen oxygen.
And the 2, H2O. Why do we say 2?
I don't know.
It's 2 particles of hydrogen and 1 of oxygen.
There you go. So that makes what we call a water compound. two atoms of hydrogen and 1 atom of oxygen makes a water molecule.
Molecule.
I know, the word was like on the tip of your tongue. I guess we got there in the end. So what's the difference between solid and liquid water?
So obviously the temperature of it.
It's a lot colder.
Ice is frozen.
What does it mean to be frozen then?
Cold.
Liquid water is no good for standing on. Ice is great.
Nothing other than temperature.
So everyone recognizes that temperature is important in determining whether the water is ice or liquid. Well, what's actually happening between the water molecules? What's the difference between water and ice?
It's frozen.
What does it mean for something to be frozen?
It's solid.
What does it mean for something to be solid?
Then it's like a brick.
It's like a brick. And what makes it like a brick? What's happening in there?
I don't know.
Well, what makes it a solid versus a liquid?
Well, in this case, lots of pipes going underneath. But
That makes it very cold.
makes it very, very cold, yeah.
But what's actually happening to the little bits of water?
They're attaching to each other. They're attaching to, this is all the guesswork here. I imagine they're attaching to each other. They're forming a more solid entities.
You cool liquid water down, and then at some point, what happens to it? It slows down, freezes, and stops moving.
The molecules become frozen.
How do they become frozen?
They join together. They accumulate. They coagulate.
Coagulate is not the technical term for it, but everyone was on the right track. In ice, the water molecules are basically fixed in place. They form a crystal lattice, where their only motion is vibrating. So what happens if we heat up the ice? Like, what happens when, like, a solid melts?
They all bounce out and
What are we talking about?
melt.
What are they doing?
Well, like in science, you draw little circles.
What are those little circles?
Oxygen.
Are they just oxygen?
Hydrogen, oxygen. And the 2.
And the 2.
The temperature is
higher. So the particles, they're less stable.
Yeah. Less stable?
Not stable.
Less, more free to move around.
That sounds right.
They become separate and they are allowed to move around. And in gas, maybe they're further apart. Is that what we're okay?
This is fantastic.
That
This
makes
guy's
sense.
nailed it.
All right, that makes sense.
That's awesome.
All right.
So in liquid water, the water molecules not only vibrate, they can also rotate and slide past each other. And this is what allows the substance to flow. At even higher temperatures, the water molecules become free of that liquid and turn into water vapor. In that state, they are very, very far apart and moving very quickly. So the major differences between solid, liquid, and gas are the motion of the particles and the distance between them. Of course, you may want to meditate on these differences some more. What about the difference between a solid, a liquid, and a gas?
Oh, that's easy. I teach meditation, and it's all about the as you de-excite something. So you de-excite the mind, you get more orderliness. As you de-excite water vapor, you get water. As you de-excite water, you get ice. More orderly. So in fact, the molecular structure becomes more orderly. That's the difference.
That sounds quite reasonable. How do you de-excite something?
Well, in this case, you actually remove energy from it. In human beings, you calm their minds down with meditation.
And that works.
It
We get
does.
de-excited.
Yeah.
Does that mean if I meditate too much, I might turn into ice, though?
No, but you'll generally become cool.
Good answer, sir.
So as he was talking about in the video, you have a solid, in a solid the particles are orderly, they're arranged in a crystalline structure which is very regular. If you add energy, you can break the bonds between the solid, so the covalent and ionic bonds, okay, and the particles are then free to move around each other. They're still stuck together because they have these very weak bonds. Okay, so if you add even more energy, they move faster and faster until they're able to break apart and there are no bonds between them, so no intermolecular forces. The opposite to that would be removing energy, so cooling the gas down, that causes condensation. Okay, and then liquid to a solid would be freezing, and again you're removing energy. So we've got melting, evaporating, condensing and freezing. You can move between a gas and a solid if you remove energy very, very quickly, and that's called sublimation. So I've got a little fill in the gaps here that you can do. I'll tell you the answers in a second if you press pause. Okay, so the answers are the three states of matter are solid, liquid and gas. Gas consists of tiny molecules travelling at fast speeds. A solid has a definite size and a definite shape, because the forces between its molecules are very strong. A liquid has weaker forces between its molecules and does not have a definite shape. It forms the shape of the container that it's in, basically. And if a substance cools down, its molecules move at a slower speed. So if we have a graph of heating, you can see that here's our solid, so let's say that's ice. If we're heating it at a constant rate, so here's our time. Okay, and here's our temperature. And initially, it will just raise the temperature of the solid. But it will get to a point where it starts to melt, and all the heat energy that you're adding to the solid, instead of causing it to raise the temperature, it goes into breaking the bonds. Okay, and so it melts. As soon as it's all melted, okay, the temperature will start to raise again until you get to the point where it's going to boil, in which case all your energy is going into breaking the bonds between the liquid, and then once that happens, all the bonds are broken, it turns into a gas, and you can raise the temperature of the gas. So this is a great graph to be able to describe. And then this is the opposite, so a cooling graph would show that as you remove energy, as time increases, the temperature will go down until you get to a point where you're trying to remove energy so that the bonds can form, which is happening here, and then the temperature of the solid will go down. Okay, right, I'm going to pop a little exam question into the classroom for you and you can have a go at it.